Okay, I'm taking my HQ brand cooktop and made my own circuit board from the components taken out of another one, spare one I have. So it's not going to have all the features of the cooktop. It'll be simple and should draw less power. And these are 10 UF caps, 10 UF. These are kind of specialized ones made for cooktops. You can find them on eBay. And the final one here goes across the coil, the big coil here. And this is 0.33 1200 volt. And I drew all this out. Let's start from the bottom. You have the AC 120 volts in. There's a neutral and a line. And on the line there's a fuse. And then there's this one of those 10 UF caps right across it. That's this one. Here's the fuse right across. I'm sorry. First there's the small little capacitor. I call it C1. It's 270 PF. It's this little blue one. And that goes across. Now comes the C2, which is the 10 UF 275 volt AC MKP times 2. If you order some of these, get the MKP times 2 because that's the one specialized for cooktops. Okay, so small little cap first, 270 PF. Then this 10 UF one goes across. And then there's a resistor, and it's very high ohms. It's 320 mega ohms. And I have that unhooked right now. I assume that's a bleed resistor for this. I was going to try it with and without the bleed resistor. Okay, now it goes into kind of an RF filter. I guess that's what you'd call it, where it has 6 turns on one side, 6 turns on the other. And it's 0.13 ohms, 0.78 microhenries, small m, big H. And it's the same on each side. Okay, so it shoots through there. This is all to kind of like make it so what happens is not going to be shooting back into the grid. That's what I assume. And it cleans up the signal and stuff. So now it goes into a full wave bridge rectifier, which I have right here. Here's that little RF filter toroid thing. And this is 35 amps, 1000 volt full wave bridge rectifier right here. I put kind of a more heavy duty one than what they have in the laptop. Okay, so it's pretty simple from the AC 120 volt 60 hertz input all the way up to the full wave bridge. And now the positive side of the full wave bridge goes into this toroid here, and this would be a choke, and it comes out and it goes straight to output number 1, and this is what hooks to the big coil. The other side, the negative side, has another 10 UF cap across the DC side, which is interesting because you have one across the AC side and the DC side. And then finally, the 0.33 cap, C4, goes across the coil itself. These represent the connections to the big flat coil, Litz wired coil, primary coil of the cooktop. And so there's that. I like to think of it all the way up to the full wave bridge and then what comes out of the full wave bridge. Now, the chopping circuit. It's an IGBT H3OR 1353. This is the same that's inside the stock cooktop. There it is here. So I traced how to figure all this out. I just traced what's going on in here. You can see the full wave bridge, the AC going over here, the DC is the one on the left, the ground is on the right. So anyways, I also picked up some SiC MOSFETs. They're about $12 each. And I'm going to substitute one of these for the IGBT later. And this is a 120M1045. But I'm going to start out using the same IGBT that's in the cooktop. Okay, so I picked up this signal generator. Tim Tron sent me a link to this, and it's really a nice little unit. Maybe cost $10 with shipping. And you can adjust the frequency over here. And you can adjust the duty cycle as well over here. Right now I have it on 50% duty cycle and just 1 hertz. I'm just testing it. And I have a 20 ohms across the IGBT. And the signal from this goes to this 4421 chip, gate driver chip here, and then the output of that goes to the gate of the IGBT. So I have this written down here. Sorry, this is a little bit more messy than the other. So here's the signal generator. It has 4 wires coming out. 2 of them is the signal and a ground, and the other side is the power supply and a ground. It's very simple. So I have a common ground. Also, I send this wire way over here to go to the source of the IGBT over here on the right. And then notice the drain in the middle goes right to one of the outputs. And then I also have a 20 ohm resistor here. And I'm going to put an RF filter, just a little piece of ferrite tube with some real thin wire wrapped around it, a few turns. And here's how the 4421 hooks up. This is the socket type. And you see there's these two are ground and these two are positive. And this one right here is where it receives its signal. So that's what that is, the signal from the signal generator. And I have 12 volts going into this, 12 volts coming out. And they say you want about 12 or 15 volts to really drive these MOSFETs and driver chips well. So that's what I got, a 12 volt battery in my little test here. And then these two go together on the 4421 chip. And that is the output signal that goes to the gate. So you guys can kind of freeze it. Figure out how it is. So this is just a copy of the necessary components of one of these Kitchen HQ brand, $39 on eBay. That's a lot of stuff for $39. Look at this coil. The coils are nice. It's Litz wire. Notice the air gap between each wind. That's so you can get some good bandwidth. It has those ferrite bars on the back end. So right now I have this working, just testing it at 1 hertz. And it's turning this MOSFET on and off. Off, 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 off. And the MOSFET's driven by this driver chip. And the signal from this goes into the driver chip. Sorry about my voice. I've been sick with a bunch of bad stuff. So I'm going to kind of hold it right here, so if you want to copy this, it's pretty simple. So I guess next video I'll be trying this out. Here's what I got. Basically it's two 10 UF cooktop capacitors, RF filter, and an inductor for a choke, and then this 0.33 1200 volt goes right across the coil. I'll call that a resonator coil. There's the IGBT. I have a couple things of Teflon underneath it. I'm using this wire just because I have it. I'm going double thick. So that's about it. This is a real neat little device. See, watch, I'll bring the duty cycle down. What I'm hoping is I can make this run on like not 1,000 watts or 800, but maybe 300 or 400 or less, and I'll have it down like maybe 15% duty cycle, so it's only on 15% of the time. So I guess that's about it. Thanks for watching.